Okay, this kind of refers back to the depth versus time model. And if you've seen that video, you understand a little bit more about why we would set up a set of axes like this. But even if you don't, we're looking at, you fill a cylinder with water, you let it flow out the tube down here at the bottom, see it flows out of the tube, okay? And if there's a lot of water in here, it flows out pretty fast. If you got a bigger hole down here, it flows out pretty fast. So we're talking about a cylinder where the water starts at a depth of 32 centimeters. And it takes 8 seconds for the water to flow out. And the model is going to look something like this. Going to have a parabola that models the depth versus time. So if you look at any time between 0 and 8 seconds, you can come up here and determine what the depth is. Okay, well, we're not going to actually do that. Just giving you a little background here. What we want to get to is that a 4x4 square usually doesn't look square. Now, you'll agree that if depth starts at 32 centimeters, it's reasonable to use 32 centimeters here. If it takes 8 seconds, it's reasonable to use 8 seconds here. In the graph, might well look something like this. Now, if I draw a 4x4 square, where here's 8 units on this axis, and here's 32 units on this axis, the units on this axis are going to be much smaller than the units on this axis. You've got to have 32 of them from here to here. You only have to have 8 of them from here to here. So what does a 4x4 square, our standard 4x4 square for a toolkit function, what's it look like? Okay, well, we divide the 8 seconds in half, and we get 4 seconds. Now I've got the seconds marked here and the centimeters marked here just to emphasize. Since I wrote y equals depth in centimeters, I really shouldn't even have the centimeters there. We understand that this would be 32 centimeters. And since t is time given in seconds, I don't really need to put the seconds there. So I'm not going to put units on the rest of the numbers. Anyhow, there's 4. And here's 2. And of course, if this is 2, then -2 will be an equal distance on the other side of the axis. Okay, so right here is the base of our 4x4 rectangle, which of course has a red dot at the origin. Now we want to do our 4-unit height here. How do we do that? Well, we cut the 32 centimeters in half. Be a little careless here. We get about 16 here. We get about 8 here, and we get 4 here. So our 4x4 rectangle, which I'll skip the color, just to emphasize, okay? Right here is our, the end of this chalk is wet from what I just did. It's the depth thing. But here's our toolkit 4x4, say 4x4 rectangle. When we distort it, it's going to be non-rectangular in this case. It's going to actually look non-rectangular, but it's actually our 4x4 square. But it looks like a rectangle that's a lot wider than it is high. Okay. And of course, then our toolkit function goes from here to here, if we're using the toolkit squaring function. Toolkit function we saw right there in the graph. Okay. Now the question that follows is, how do we have to distort this graph to give us at least this portion of this graph? It should be clear that this is the portion of the graph. This is the portion of the graph that models this curve. And if this is the depth of water in a cylinder versus clock time, once the water is out and the flow stops, it's not going to fill up again. So we only need this part of the graph. Okay, well, went a little bit beyond the main point here that a 4x4 square doesn't usually look square. Because usually you're not going to have equal units on the t-axis and the y-axis. The t and the y-axis, whatever, the horizontal and vertical axes don't measure the same thing. And even if they do sometimes measure the same thing, they might measure a lot more of it in this direction than in this direction, or vice versa, a lot more of it in this direction than this direction. Well, the point is that when you have graphs, you don't expect to have equal scales in both axes. And when you don't have equal scales, you don't get a square, a 4x4 square that looks like a 4x4 square.